So, what are some of the pieces of the puzzle when we're creating a design? What do we need to investigate? Well, with any design, there are many drivers and requirements that we typically have to meet. It's important to make sure that we're using our entire tool set to get the most information. Pieces of this information are going to influence my decision-making process along the way. And it's easy to argue that more information is always better than less information. The faster we have all the information, the faster we can connect all the dots, get our products released, and get them to be higher quality. So, what does a typical process look like today? Well, over the last 10 years or so, we've seen a lot of companies adopt technologies such as FEA and simulation, along with 3D CAD, to be able to reduce overdesign, save cost, and really just allow for greater design insight. The problem is that we have a lot of downstreamers. Things like marketability and creating technical publications usually come later after the design is pretty much underway. Redesigning for cost is typical when we're at the point where it's going to cost a lot to do that redesign. And then finally, we have tertiary people that are doing things like the maintenance documents and even evaluating ecological impact. So these downstreamers on revision C, how much flexibility do they really have to change the design, and how much time is left? So we can work smarter. We can leverage all the tools inside of SOLIDWORKS to accomplish more. Then, all of a sudden, there's not so many downstreamers, and this is simply working smarter. Let's make the initial revision tighter by getting as much information up front as possible, so revision A is the best it can be. We're going to use tools to look at safety. We're going to look at tools to see how much this is going to cost, and we're going to use tools to see what the environmental impact of my design is going to be up front. As I mentioned, we can evaluate safety using tools like simulation that companies have really jumped on board with over the last 10 years. But today, we see companies that want to adopt sustainable design practices and create greener products. However, sustainable design presents a big challenge. How can they design greener products? How can they do it in an authentic, credible, and reproducible way? Well, let's see how SOLIDWORKS lets us design better and connect all these dots together in the design of this control panel. Inside of SOLIDWORKS, we're looking at the cost of each component. So when I want to task my designers with working on where they can have the most impact, well, we can see that this sheet metal enclosure is actually driving a lot of cost to this assembly. Now, if we take a look at this sheet metal piece, remember there's 4 drivers I have to meet. It's got to be safe, has to not weigh too much, it's got to be cost effective, and I want to consider the environmental impact. We can see this component is made out of sheet metal. In fact, it's just a plain carbon steel, such as a 1023 steel. And the first thing we want to do is make sure that the design that we have is going to be safe. And perhaps on the floor, we actually do a crush test on all our components to make sure they're not going to collapse under normal use. So of course we all know that simulation is what allows us to digitally test for things such as safety right inside the box. So I know right now, based on the thickness and the material I've chosen, is this component going to survive? And we get a lot of instant design feedback with simulation. For example, I'm looking at stress right here, but I might want to look at displacement. How much does this thing deflect when I put on the crushing force? And it sure looks like a lot, but this is magnified a couple hundred times. Now, for safety, we typically look at factor of safety. And what this does is compares the material's stress to the yield strength. So what you see here is everything's blue. And if you look on the legend over here, you'll see that blue is 10 or higher. And really a factor of safety of 10 or higher is just high. It's, in fact, over-designed. What we want to do is use enough material to be safe, but not over-design, so that's going to drive the cost up. So what we can do is set up a design study inside of SOLIDWORKS. And what this is going to do is allow me to automate parameters. And in this case, the major parameter that I have is the thickness, right? I can use 8 gauge, I can use 20 gauge, and then, pretty much anything in between. So I can set up my design study to automatically evaluate every one of these different thicknesses. What that allows me to do is get a lot of information up front. So when I have to decide which material I'm going to use, well, I can set up the design study to go through materials, go through thicknesses, and ultimately, the net is I have a lot of information to help guide my design decision. So for example, what you're seeing here is basically what passes and, well, what fails. And you can see that the green here represents my criteria of a factor of safety of 3. So basically I want it to be 3 times stronger than it really has to be to withstand that crushing force. So we can see for all my steel materials, I'm going to need a 14 gauge material. If I want to use my 6061 aluminum, I need to use a 9 gauge. Now everything above that passes, but if I start using 12 gauge, 10 gauge, that's where we get into the over design and really the too high of a cost option. So the optimum solution is right around here. But that's only one piece of the puzzle, right? We also want to look at the cost. So how much does it really cost, and how do I figure that out inside SOLIDWORKS? Well, new in SOLIDWORKS 2012 is a tool called sheet metal costing. And what this allows me to do is figure out, based on the material, based on my manufacturing costs or my vendor's costs, what this sheet metal component is going to cost. So out of the box, there's some templates. We can set up the material, the gauge that I'm going to use, and then figure out down here what this is going to cost. So what we want to do first of all is set a baseline. Using my carbon steel 9 gauge, which we saw was kind of over designed, I want to set that as my initial design, see how much that's going to cost. And you can see it's about $47. And if you look over here, this is basically where it's tallying up and aggregating all the different costs. And again, these are set up in the template. It's really like an automated spreadsheet, if you will. But it's going to aggregate the cut path, whether I'm using a laser or a water jet. It's going to count the number of bends. It's also going to include things like setup costs. Now, since I'm using plain carbon steel, I'm also probably going to want to put this through some kind of paint treatment. So we can also do custom operations, such as paint this based on a certain cost per unit area. And again, that's all set up in my template. So I know that this part is going to be about $50 to create. So from here, I can now start investigating different geometries or different materials and figure out what the cost difference is going to be. So we saw in my factor of safety report that I really just only need a 14 gauge piece of steel to pass. So look at that. Over designing would have almost doubled the cost. But I have a lot of different material options here too. I also have the ability to use stainless steel. That's another option I have. But how much more does stainless steel cost than plain carbon steel? Well, you can see it's about double the price. But if I'm using stainless, I probably don't have to paint it. So again, I can take operations like this and remove them. But we still see I'm looking at $95 versus about $30. So about a 3-to-1 cost ratio. So using the tool called costing, I can figure out the cost impact of all my different design options. So let's take that same kind of information and apply it to my graph. So as we'd expect, as the thickness goes up, my costs increase. So where we want to be is right here at my minimum requirements. But I get a lot of feedback here, right? And whether I'm evaluating different materials or different geometry options, I can see that what I select either has a big impact or a smaller impact. So I could easily use galvanized steel or plain carbon steel. Yeah, it's pretty much the same. Then I get up to stainless steel and I see that that's really where I get the cost that's going to be about 3 times higher, running all the way up to about 10 times higher depending on the thickness that I use. So I'm starting to put these pieces together and connect these dots. But the last thing I want to look at is the environmental impact, because as long as I'm getting this information, I might as well have an idea of what the ecological impact is of my design. So inside SOLIDWORKS, we also have a tool to evaluate that. And that tool is called sustainability. Now, sustainability is a great tool that's going to allow me to figure out what things like my carbon footprint is, what my air impact, my water impact, and how much energy I'm going to use. And what's really cool is it's not just looking at the material itself, but it's looking at the actual use. Where do I manufacture this? How long is this built to last? What process did I use to manufacture it? How much energy did that take? And then where am I going to use it? So looking at the actual use phase. Is it transported by air, boat, truck? And at the end of the life, where does this thing go? Are people going to recycle it? Are people going to burn it? Or are they going to landfill it? So, for example, if I assume that 50% of people are going to recycle it, fewer people are going to compost, I can see what the impact of that's going to be. So I know if I need to put across a recyclability initiative or something like that. So let's look at some of the outputs of these tools. As I mentioned, we can look at the 4 different environmental impacts that this design, use, and end of life are going to have. Water impact in terms of phosphates, air in terms of sulfur dioxide, how much energy this is going to use in manufacturing, disposal, and also use, and then my carbon footprint in terms of kilograms of carbon dioxide. As I mentioned, these 4 different impacts come from various places, including the material, processing and extraction, the manufacturing, the use, and then the end of life and transportation. So it's a very granular analysis of what's going on with this material choice or this geometry choice and how it's going to impact the environment. Just looking at making one part in these 4 different materials, you can see there's a whole range of energy usage differences based on the material I select. So for example, using 1023 versus 304, that's like watching TV for a whole extra day. You know, my father always said, turn the TV off when you leave the room. And looking at this, every part we create using stainless instead of carbon steel, it's like leaving the TV on for an extra day. And then how about carbon footprint? Well, if we take a look at the average American automobile, the carbon impact of using steel, the 1023 carbon steel versus 304 stainless, well, you see it's about 18 miles, and that's per part. But, let's assume we make 1,000 of these. That's 18,000 miles of difference for just a 1,000-piece run, and that's like driving coast to coast 6 times. So let's put all these information pieces together. Let's connect all the dots. First of all, we know what passes. Every one of my material options can pass the safety test. I just have to pick the right thickness. Of course, if we're going for a weight, aluminum is hands down the best choice. We also saw with costing that galvanized and carbon steel, they're the best choice. And also, by far, the less environmental impact comes with the 1023 carbon steel. Now, things that are kind of questionable but would still work would be the weight. So, of course, the steel is just not going to be able to compare to aluminum if we're going for weight. And we can also look at the environmental impact down here for the galvanized and the 6061. It's just a little bit worse than the carbon steel. And finally, the red, where it's just way worse than the other options. Stainless, we saw the cost was 3 times higher. The ecological impact was just ridiculously higher. So using all that information, I can now go to my design review and say with confidence, I am choosing the best option here. And looking at these options, I'd probably go with the 1023 steel. So after picking that material, we can go with confidence into our design review and say why we chose a material or a geometry or this or that, and have that information up front very quickly inside SOLIDWORKS. Now, sustainability is kind of a new idea. Like I mentioned, simulation over the last 10 years has taken off, and everyone knows the benefits of using simulation with your digital model up front to avoid all the costs. But, like I mentioned, sustainability is the next big step for a lot of companies. How do we make our design practices sustainable, and how can we quantify our environmental impact and use that to make better products? So we see a lot of companies doing this, and it's actually improving the bottom line, right? If I'm using less energy, if I'm putting less carbon into the environment, I'm going to be able to save money simply because I'm not using those raw resources. My products are going to be better, and I think most importantly, they're going to appeal to a brand new audience. Think of all the products we see in the marketplace that have green logos or are marketed towards a green consumer. So check out this Harvard Business Review article that goes over some of the new ways that companies are innovating and using sustainability as the cornerstone of that innovation. So we saw how we could use SOLIDWORKS to look at factor of safety with simulation. We could estimate the cost of my sheet metal component using costing. I looked at my environmental impact with sustainability. And of course, weight is just a property we get because we're using 3D CAD tool such as SOLIDWORKS. And there's a lot of business benefits to having these tools. One of the things we see over and over again is as you get further in the design cycle, changes become more time consuming, they become more costly, right? You have tooling set up, you have vendors set up, you have materials ordered. So the more information we get up front always makes our design better. So some of the best tools that we have up front are the things we have right inside SOLIDWORKS that allow us to evaluate these models. To me, the bottom line is this. More data is always better than less data and is going to guide our decision-making process the entire way.